book makes an abbreviation. Well, the sum of the moments about x equals 0 is just, that's the net effect of the moment about x equals 0. And your book, just to make it confusing, calls this m sub y. So why is the book using y to calculate x bar? Because that y refers to the y-axis. It's always get confused when using these, so I think it makes more sense to call it x equals 0 to match the x that we have here. But if you're trying to follow this in the book, be aware the book is using m sub y. And then for the y bar, it's almost the same thing, except we do the sum of the moments about y equals 0 divided by the total area. And notice the denominators are going to be the same. And y equals 0 is a horizontal line. So I'm trying to make a slice so that every point in that slice is the same distance from y equals 0. Would that be a horizontal or vertical line from the original region? It would be horizontal. So for the y bar, I'm going to be taking horizontal pieces like this. So a moment, just like we had on that balance or on that scale, that balance scale, is going to be the distance times the weight. And I'm using area as a proxy for the weight because I adjusted the density. I don't have to worry about it. So first of all, I need the distance from y equals 0. And that is a vertical distance. Vertical distances are measured by y. And specifically what y measures is the vertical distance from the x-axis. So when I have distance from y equals 0, that's just y. It's for the area of this rectangle, I need base times the height. Let's see, the height of dx or dy? dy. And for the base of this rectangle, horizontal measurement or vertical measurement? Horizontal. What letter measures horizontal things? Yes. So what I'm going to have to do is get the x's for each side of this rectangle. Remember, the rectangle came from here. So for all the horizontal strips, what's the x value on the right side? So on the right side here is always 4. And on the left side is it's always on this graph. So down here they're long, up here they're short. So for the left side, we have y is equal to x squared. So for us, we need the x equals. So this distance is 4 minus the square root of y. You all right? So what I said was everything on here has an x coordinate of 2. And that means that this right side is x equals 2, which is 2 minus 1. That's what I said, right? Okay, so the area is going to be the base of this rectangle, which is a length of 2 minus root y, times the height, which is dy. And then is that dy tells me I'm using horizontal strips, and it's each point along the y-axis that gives me one of the strips. What's the y value at the very bottom of this region? And the Y value at the very top? 4. You have to evaluate these integrals? It depends. On the exam, no. On the homework, yes. What do you do on the homework? Simbo Lab, Wolfram Alpha, your TI-80, whatever, the TI Inspire. So any technology you need. So I'm more interested in you setting those up. You want to talk a little bit about horizontal strips. Horizontal strips are useful when they're uniform. So in other words,